we're going to go over two things, some logarithm rules and also a change of base formula. And change of base formula is simply how do you type like log base 5 into your TI-84, because you only have the log, which is base 10, or the ln, which is base e. One thing I want to add to this before we go is if I have the log base a of x, I'm going to require that x be positive. We can't take the logarithm of anything that's negative or even 0. This should make sense, because if I ask you log base a of x, let's just say this is equal to b. If I could plug in 0 for x, then that would mean that a to the b is equal to x by rewriting it as an exponential. And so you would be saying that a to the b equals 0. And keep in mind, we required that our base for our logarithm be positive. So how can you take a positive number to any power and make it equal to 0? You can't do this. So we are going to require the domain for all of our logarithms, whether it's base 10, base 5, base Snoopy, base e. There's really no base Snoopy, don't worry about that. Although that would be crazy cute. If you have a log base Snoopy, that would be a new interesting mathematics, you know. Log base Snoopy of, I'll stop being silly. Anyway, all right, here we go. So let's learn. All right, so we're going to talk about, again, our base has to be positive. We already know this first bullet. This is how you rewrite a logarithmic statement into an exponential. And we're going to require that x is greater than 0, so the domain of logarithms has to be positive. Now, there's next two you haven't seen yet. And this is basically giving us an idea that logarithms and exponentials are inverse functions. And inverse functions will cancel each other. So if we have inverse functions, and if you do a logarithm and an exponential, they're basically supposed to cancel each other, and this answer is just x. The next example here, if you have an exponential and then a logarithm, those should cancel each other, and you have just x. So you need to know those two properties for logarithms. The first one you already knew. All right, so let's go through what we need to learn today, and that is the laws of logarithms. Logarithms work a lot different than any of your polynomials. They're not polynomial functions anyway, so they work different. And so we have these three. These are the three main ones. And this says that if you have the log of a product, it is equal to the log of the first factor plus the log of the second factor. No other function behaves that way. And the second one is if you have the log of a quotient, then this is equal to the log of the numerator minus the log of the denominator. Then it says, the third one is if you have the log of something being taken to a power, the power can be brought down in front of the logarithm, and it can be r times the log base a of x. And these are unique to logarithms. No other function behaves this way. So this is going to be new for you to see, although you probably saw it in Algebra 2. The last thing I want to do is your change of base formula. And this is going to be very useful if you want to do something like the log base 5 of a number. So let's just do that example. Let's say I have the log base 5 of 7, and I said this is equal to something, and I wanted to do this. And of course 7 is not a 5 is, you can't take 5 to any power and get to 7, so you can't answer this without a calculator, and there's no log base 5 button. So the way we do this is we go ahead and convert this into an exponential, and then we're going to take the natural log of both sides. Natural log of 5 to the x equals the natural log of 7. And then I'm going to take that third property that is on this previous page, this third property that says if you have a logarithm, if you have an exponent, then you can bring that down. So this x is that exponent, so I'm going to bring that x down in front, and then I'm going to solve this for x. So I'm going to divide both sides by the natural log of 5. And I get that x equals the natural log of 7 divided by the natural log of 5. So let's take a look how that matches our change of base formula. So if you have the log base a and your calculator doesn't have that base, like your calculator doesn't have log base 5, unless you have an iPhone. Your iPhone will do this. If you have log base a of x and you don't know how to do this on a calculator, you take the natural log of the x and you divide it by the natural log of the base. You see how that worked over here when I did all this work? All this work, by the way, is simply just a proof of the formula. I don't want you to go through this process every time. I want you to trust the change of base formula. Trust this. So see how log base 5 of 7 turned into the natural log of the 7 was on top, divided by the natural log of the base. So if you have a logarithm that you can't plug in your calculator, this is called your change of base, so you can plug it in on your calculator. And this value right here would be the same thing as the log base 5 of 7. Alright, so now we're going to go through the fact that the natural log obeys all of the logarithm rules. Natural log of a product is the natural log of the first factor plus the natural log of the second factor. The natural log of a quotient is the natural log of the numerator minus the natural log of the denominator. Again, if you have the natural log of something being raised to a power, that power can come down here in front. Again, we know that natural log has a base of e, and so to convert a natural log statement to an exponential, we use the base e. And of course, natural log and e, these are, or the exponential e to the x and the natural log, these are basically inverse functions, and so they'll cancel and they'll give you x. And then e to the natural log also cancels and give you x. Let's do some examples. Expand log base 3 of 2x. Well, this matches our very first rule. Let's go back and look at that very first rule for LOG. The log of a product is the log of the first plus the log of the second. Again, this is unique to logarithms. So this would mean that this is the log base 3 of 2 plus the log base 3 of x. Boom. Expanded. Alright, let's do the next one. This is the second example of logarithmic properties, and I have the log base 4 of a quotient. So this is going to be the log base 4 of 16 minus the log base 4 of x. And here I can go a little bit further because the log base 4 of 16, I can answer this. And this means if we convert this into an exponential and we say this is equal to something, I get 4 to the x equals 16. And this is what we practiced on Wednesday. We can write 16 as 4 squared, so x is equal to 2. So the log base 4 of 16 is 2. Alright, let's go to our next example. Expand log base 5 of x cubed. Well, this is the third property of logarithms, where this exponent can come down in front, and this is 3 times the log base 5 of x. Pretty simple. Let's get a little bit more complicated here and have several things together. Here I've got the log base 2 of, in the numerator I've got a product. I've got 8 times x to the 4th, and in the denominator I've got 5. So this can be rewritten as the log base 2 of, I'm going to write the entire numerator, 8x to the 4th, minus the log base 2 of 5. And then I can even go further because I've got the log of a product here. I can say, well, that's the log base 2 of 8 plus the log base 2 of x to the 4th minus the log base 2 of 5. And I've got two more things to do here because I can answer the log base 2 of 8. It's 2 to what power gives you 8? That's 3. And then I can bring the 4 down in front because of that third property of logarithms. And I have it completely expanded. La 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 la. Alright, let's keep going here. Let's expand this one. So again, I've got a quotient, so I'm going to do the log base 3 of 4 times x minus 5 squared, and then minus the log base 3 of x to the 4th times x minus 1 cubed. So let's see what we can do here. I've got the log of a product and the log of a product. So I'll do the log base 3 of 4 plus the log base 3 of x minus 5 squared, and then minus, and I better put this in parentheses because it's minus all of this, the log, well, or brackets, the log base 3 of x to the 4th plus the log base 3 of x minus 1 cubed. Let's see, what else can we do here? The log base 3 of 4 cannot be simplified because 3 to a power does not equal 4, at least an integer power. And then here I'm going to bring the 2 down in front, 2 times the log base 3 of x minus 5. Now I'm going to distribute this negative through, so this is going to be minus the log base 3 of x to the 4th, and then minus the log base 3 of x minus 1 cubed. And so my last step will be to bring those powers down, and my final answer here will be the log base 3 of 4. We're going to make that look better. Off we go to the eraser. Back to our marker. The log base 3, that's better, of 4, plus 2 log base 3 of x minus 5 minus 4 times the log base 3 of x, and then minus 3 times the log base 3 of x minus 1. I have it completely expanded. Alright, let's talk about simplifying, as in bringing logarithms together. So I'm going to go backwards. If you go back to your properties, I'm going to go from the right side to the left side. So if I have the log of a sum, this would be condensed or simplified to the log base 2 of x times y. Now I can only do this if we have the same base. Let's do another one. I'm going to go ahead and bring together the things that have plus signs on them, and the minus will be a dividing. But before I do that, I'm going to take the number in front and bring it back up as an exponent. So this is going to be the log base 2 of x cubed, and I'm going to bring this plus log base 2 of y over, and then minus the log base 2 of x plus 3 to the 4th. So I moved this log base 2 of y over. Now I'm going to condense these into the log base 2 of x cubed y divided by, and it's divided by because that's a minus, x plus 3 to the 4th. And it's the log base 2 of all of that. Alright, last thing I want you to think about, and this is going to give us something to think about, is I'm going to take a look at the graph of y equals the natural log of x, and then I also have the graph of y equals the natural log of 2x. So you're going to see both of these graphs, so let's go take a look at that. So my question to you, something to think about, you can see on this screen here, but I'm going to take you to the graph screen. Why are these two graphs, why do they have the same slope at every single x value? Why does the natural log of x and the natural log of 2x have the exact same slope? Why isn't the natural log of 2x twice as steep? So see if you can answer that when I see you tomorrow. And I will see you guys tomorrow.